بالإنجليزي بلش. Good morning, dear participants. We are in one of the presentation days that will become routine, inshallah, I hope. Today, two distinguished researchers from Turkey will present their valuable work to us. Ahmet Bedei Aman present the first presentation, and second one, Abdul Qadir Bal, will present the second presentation. I would like some information about their Mr. Ahmed Bedei Aman, who has been serving as a researcher at the General Directorate of Agriculture Research from Ministry. His research primarily focuses in precision agriculture technologies and energy efficiency in agriculture, where he has contributed to various innovative projects and field applications. In addition, his professional work, currently in the final year, PhD in Ankara University, combining scientific research with practical agriculture applications. He aims to advance digitalization and sustainability in agriculture production, making valuable contribution both the academic and applied dimension of the field. Mr. Ahmed, if you're ready, you can start, please.
Yeah, I can start.
Yes. Buyurun Ahmet.
Can you see my screen?
Ekran, tam ekran yapabilirsin.
Tamam, şunu ben bir satayım. Şu an tamam mı?
Yok, tam ekran, tamam, şimdi tamamdır. Ses de iyi, gayet güzel. Tfadal.
Ayarlayayım. Tamam. Pardon.
خلاص يحصل.
Ahmet, ses
Okay,
gelmiş.
I will start.
Tamam.
Okay.
Tamam. Şimdi gelin. Evet.
Okay. Today we will talk about the future of precision agriculture, focusing on the variable rate application in the decision support systems. We can shorten it variable rate application as a VRA is a farming method that allows us to use inputs like fertilizers, seeds, pesticide, and water in different amounts depending on the needs of each part of the field. Instead of giving the same amount of everywhere, we give the right amount to right place. This helps farmers use inputs to more efficiently save money, protect the environment, and increase crop yields. That's why VRA is one of the key tools for modern farming. And variable rate application are usually grouped into two main types, map-based and sensor-based. In the map-based approach, special prescription maps are prepared. And before by using data like soil analysis tests, yield maps, or satellite or drone images. Then farm machinery follows the maps to apply the right amount of inputs in each part of the field. And the sensor-based application, on the other hand, real-time sensors measure crop or soil conditions directly in the field, and the application rate is instantly adjusted based on the measurement at the moment. And together, these two approaches enable more precise, efficient, and sustainable input management. And in both method has advantages and disadvantages. The advantage of the map-based applications includes its use of comprehensive historical data like soil analyze, yield maps, and satellite or drone imagery to provision to detailed planning before the season. And it works well for large-scale farms, consistent field management, and it has the disadvantages for these methods are it's required prior data collection and analyze, so it's definitely need time and cost, and less flexible in the responding to sudden field changes like weather or pest outbreaks. In the sensor-based applications, the advantage of those models is its real-time measurements and adjustment in the field, its ability to respond quickly to spatial and temporal variability, and its reduction of the need for extensive precision data collection. The disadvantage of this method is include obviously high initial investment at the beginning in the sensors, and the calibration is a problem in this case. So, and the sensor accuracy may be affected by environmental factors because in the field conditions, it can be dust or water or humidity in the sensor, so it can be a problem. And variable rate applications are used for managing various agricultural inputs, like including variable rate fertilization, variable rate pesticide application, seeding, and irrigation. In the fertilization, adjust the application of nutrients such as nitrogen, phosphorus, and potassium in the right amounts for each part of the field. It uses information from soil analysis, crop needs, and past yield data from decide how much fertilizer to go. This way, nutrients are used more efficiently and costs go down and negative effects on the environmental are reduced. In the variable rate pesticide application, focus on pesticide use where it's really needed, higher doses in the problem areas and lower doses in the low risk zones. By adapting the actual field condition, it cuts down the chemical use, protect the environment, and still keeps pests under the control. Variable rate pesticide applications can be done in two ways. One of them is spot spraying. It uses maps or imaging to target only weeds or infected areas, or nowadays is hot topic to sensor-based spraying, uses real-time sensor or cameras to detect plant health or weed presence in the field and adjust doses instantly. Both methods save chemicals, cut costs, and make pest control more efficient and sustainable. Variable rate seeding can be implemented using a prescription map derived from soil sampling, yield maps, or remote sensing data. It can also be done through the real-time sensor based on systems to measure soil properties like EC or like that on the go. And modern planters equipped with electronic meters and GPS guidance allows for precise control of the seed decrease across the different field zones. Variable rate seed adjust planting density based on the soil fertility and expected yield potential across the field. High potential areas receive denser seed population, while lower potential zones are seeded more sparsely. This optimized resources use, improves crop uniformity, and increases overall productivity. In the variable rate irrigation is modern technology that optimize water use in agriculture. Unlike conventional irrigation, it considers the natural variations in the field's soil, slope, and crop needs. Variable rate systems, irrigation system use high-tech tools like GPS, satellite data, and sensor to apply the exact amount of water needed to each specific part of the field. These systems can work by adjusting the speed of circular pivot irrigation or by applying water to smaller divided zones with the field. And the decision support system is one of the key in the actually in the variable rate application. To achieve efficiency and sustainability in agriculture, inputs like fertilizers, pesticides, seeds, or water must be applied at the right place at the right time. Variable rate applications have achieved this, but they need complex data from many sources to be collected, processed, and turned into actionable decision. This is where decision support systems come in. Decision support system combine different type of field data such as soil properties, nutrient levels, climate, crop growth, yield history, and satellite or sensor data or drones data to guide farmers. They help answer the important question like which input, how much, where, and when should it be applied. This ensures decisions are coming from data-driven, not based on the guesswork. The working principle of this systems can collect data from soil tests, remote sensing, climate, and farm management reports to process it with simulations or machine learning to analyze the data and to make a recommendation for the farmers and make file to apply to tractors to machinery to apply the right amount of in the right place. The importance of the benefits of the decision support system is the economic benefits and also increase the productivity. It's time efficiency as well, and environmental sustainability is nowadays is one of the key topic in the world, and has also improved the crop quality to ensure more uniform crop growth and higher quality standards. And the role of the artificial intelligence can transform decision support system by analyzing large amounts of data from soil sensors, drones, satellites, and IoT devices. It can detect hidden patterns that traditional methods might miss and enabling more accurate prediction of crop needs, pest outbreaks, and water stress. This allows the decision support system to give high precise, site-specific recommendation for fertilization, irrigation, and seeding. And the artificial intelligence will involve in agriculture in the future. At the moment, it's already involved, but in the future, it will boast, and it will be very easy for the farmers to monitoring our daily farm. And I will want to talk about my project. It's also is variable rate liquid fertilizer application. It's still an ongoing project. It's in the second year. And the project is being conducted in the 14 acres cotton field in Şanlıurfa. This cotton field divided into two main plots, 20 acre with variable rate liquid fertilizer application, 20 acres, and 20 acres with conventional uniform application. The primary goal of the project is develop the system capable of applying the exact amount of liquid fertilizers needed in each zone by considering variations in soil properties and crop requirements. The key technical aspects to we mounted a precision GPS receiver installed on the tractor, on the top of the tractor, and the control screen in the cabin, in the electro cabin, and electro unit was installed on the liquid fertilizer machine to enable the rate control. We can control the rate with this one. In addition, isobus cables and control panel were mounted on the machine to establish communication with the control screen. Those are the technical product, we use these regulators and these cables to make connection between regulators with a screen, GPS receiver, and control unit. And this is the screen of the systems, and we can allow we can control the dosage of the liquid fertilizers inside the tractors. And to guide the application process, to NDVI reflectance and soil analysis were used to classify the field in the 5 management zones. The fertilizer solution was calibrated to provide, according to literature, 12 kilo of pure nitrogen as a top dressing within the experiment or in the control plot. This amount was applied uniformly. In the variable rate application, 5 classes were defined for the 12 kilo, 10% and 15% less, and 10% and 50% more. We detect and we divided in the 5 classes at this point. And the field was mapped according to these classes. And we prepared the prescription maps and upload it to screen in the tractors and give the exact amount of what we need. These are the classes we divide the fields. It's according to soil analysis and NDVI reflectance. There was a 5 class. And this is the whole area with classification. And this NDVI reflects historical data during the period. And the first circle was when we applied the fertilizers, the top fertilizers. And the second circle when we applied the defoliant for the harvest. And the result, we use very little amount. Yeah, there was nearly none in the fertilizer use, just 12.5 liters less we use in the variable rate plots, but we get 20% higher production in comparison with the traditional methods. So it means like $45 per decar we save money in this methods. So this were our cotton fields. And thank you. And I was happy to answer your questions.
Thank you, Mr. Ahmed. Have any question, dear
والله كيف
participants?
الحال؟ شو الأخبار؟ كيف الصحة؟
دكتور مبارك.
الله خير. والله الحمد لله.
تفضل.
لا يبدو بالغلط دكتور، ما كان
غلط اوكي.
طيب ما بعرف
سؤال
عنده
موجود
سؤال ممكن؟
Any question? I think very clear. واضح كل شيء.
ما في أسئلة دكتور، ممكن إنه نبدأ مع عبد القادر وناخذ الأسئلة ككل بعد المحاضرة.
اوكي.
برزنتيشن عبد القادر ممكن؟
Mr. Abdul Qadir Bal.
Yes.
1 minute, please. Mr. Abdul Qadir Bal has been serving as a researcher at our institution for 5 years. His research primarily addresses the challenges of climate change and drought, mainly. Throughout this work, Mr. Bal aims to contribute to the development of the sustainable agricultural practices and climate-resilient land management approach. Mr. Abdul Qadir,
Yes.
are you ready? Please, you can start. Thank you.
Just a second. Ali abi görünüyor mu?
Ekran gelmedi, sen görünüyorsun.
Gelmedi mi?
Evet.
Bir dakika.
Ekranı paylaş.
Bir dakika başkanım. Şey kapandı da sunum kapandı. Şimdi paylaştım ben.
Ahmet Bey, bu arada aşağıda soru geliyor. Soru kısmında
Evet.
onu cevaplayabilirsiniz.
Hı hı.
Gelmedi Abdülkadir Bey.
Mr. Abu Ahmed asked how much different between using traditional way to spray chemicals and these systems. And in the spraying as well, especially, it's very really useful because it can reach like 20% of saving the chemicals because of the spot spraying. We can detect where the disease or the weed in the field and in the exact location and mark it with both in the pulverizer or in the drone spray, so we can apply this to maps, or it can be also in sensor based and apply just in the weeds instead of applying all of the field. So it can reach nearly in some areas 80% of less chemical use in the for the spraying, but in the fertilization, it's like a variable rate applications according to our work and in the work done in the past is like 20% of efficiency, 20% more we can get higher productivity and in total and less cost, less input. But in the spraying, it's really effective.
Thank you, Mr. Ahmet. Thank you, Abu Ahmed, for nice question. Dr. Abdülkadir, what
Küçük
do you
bir
do?
küçük bir problem yaşıyorum da. Şu anda gözüküyor mu?
No. Presentation not open. No.
Şimdi
No.
Allah Allah. Niye böyle oldu?
2 dakikanızı rica edeyim, o tarafa geçeyim.
Tamam Ahmet Bey, evet,
Bilgisayarda bir problem.
Tamam.
bilgisayarla ilgili bir problem var. شوي مشكلة شيء بالكمبيوتر ما تنفتح presentation يغيرونه خلال دقيقتين إن شاء الله كامل.
ما في مشكلة دكتور، بس دكتور عم يبعثوا لي إنه إذا بدهم الماتيريال، إذا ممكن البرزنتيشن، إذا ممكن يزودونا فيه كPDF
Okey.
بعد
Abdülkadir Bey,
إن شاء
Ahmet
الله.
Bey, sunuları PDF formatında Doktor Raya'ya gönderebilirseniz iyi olur.
Tamam, okey.
إن شاء الله. في
İnşallah.
كان
daha
الدكتور عبد
sonra.
المنعم أعتقد
Hı
عنده
hı.
سؤال
Doktor Abdülmenam,
من الأكساد.
نكسات تفضل.
الله صباح. يعني أنا كان النت شوي ما سمعت كثير، المحاضرة تقطعت، لكن أشتهي أسأل أشكر الدكتور الأستاذ أحمد على الموضوع وعلى العرض يعني السريع جدا لكن أنا أشتهي أسأله يعني صار في هناك مقارنة يعني بين الزراعة التقليدية من حيث والزراعة الذكية باستعمال المعايير اللي ذكرها. من حيث الغلة هاي واحد، إنه زاد المحصول أو نقص، أو ما هو الفارق يعني اللي صار بين الزراعة التقليدية والزراعة الذكية. واثنين، السؤال الثاني وهو مهم يعني أعتقد إنه القيمة الاقتصادية، يعني الكفاءة الاقتصادية، إنه هاي فيها كفاءة اقتصادية يعني من حيث الأجور، من حيث الكميات، الوفرة المادية.
Ahmet Bey.
عيد أحمد بيك.
Ahmet Bey.
There are difference between the agriculture traditional agriculture and artificial
مفهوم واضح
culture.
واضح كل شيء
Okay.
واضح يعني Ahmet Bey Dr. Ahmet Bey duyuyor musunuz sesimi?
Başkan bir dakika.
Ahmet Bey.
Evet.
Ahmet Bey şimdi bir soru geldi. İstersen İngilizce cevaplayabilirsin. Senin bu uygulamalarında verim artışı oldu mu? Bu bir. İkincisi bu uygulamaların maliyeti ile karşıladığı verim birbirini kapatıyor mu? Abdülmenem Bey sordu. Cevap verebilirsiniz.
In our application, there was a 20% of difference between yield in the control parcel and in the variable rate parcels in the plots. And in the small scale farms, it's not profitable because the price of the investment for this project and this type of machinery is very high actually. But in the large scale farmers, they generally use, especially in the world, in the North America, Australia, and in some part of South America, can use this kind of products very intensively because there were very large scale of farm over there. So it's profitable because in with this especially fertilization is like 20% or 50% means a lot for large scale, but in the small scale farmers it's not profitable as we see in our projects.
Thank you, Mr. Ahmet. Abdülkadir Bey, Mr. Abdülkadir.
Başkanım öncelikle
Bilgisayar
bilgisayar değişeceğim de 2 dakikanızı alacağım. Çünkü benim bilgisayarda bir problem yaşadık. Hani, 2 dakika.
عنده مشكلة بالكمبيوتر دكتور ريا يريدون يغيرون الكمبيوتر إذا موجود سؤال
ما في مشكلة دكتور، ما في مشكلة.
أوكي.
Ben de flaşatım geliyor.
Ahmet Bedeyi, Mr. Ahmet Bedeyi. Raşit Marokko'dan soru soruyor.
Başkanım bilgisayarı düzeltip hemen geliyoruz. Diğer bilgisayara geçeceğim. O da Ahmet de yanımda.
Tamam.
Hemen çözüp şey yapıyoruz.
O arada soruları da not etse Ahmet.
Yazılanlara bakarak başkanım oradan cevap verir.
Tamam. Okey. 5 دقائق أو 3 دقائق اشربوا شاي استراحوا شاي
لا.
مية قهوة
اوكي هيك.
فتح.
تمام.
Okey. Abdülkadir Bey açıldı. Tamam. Vadah مبين. Abdülkadir Bey problem kalmadı.
Tamam.
Yalnız ses konusunda biraz sesinizi yükseltseniz tamamdır.
Okay. I am sorry, I have a problem, my computer problem.
Ses yok. Ahmet Bey. Abdülkadir Bey. Ses mikrofonu biraz yaklaştırabilirseniz. İkinizin de sesi kapalı şu anda. Ahmet Bey. Abdülkadir Bey mikrofon kapalı. Abdülkadir Bey açıldı.
Valla geliyor mu?
Geliyor da sunum nerede? Tamam şimdi geldi okey.
Sunum da geldi mi?
Okey her şey tamam.
I am so sorry, I have a problem, computer problem. Today I will present my work under the title Measuring the Plant Root Carbon and its Contribution to Soil Carbon Storage, the Mixed Space Approach. In this presentation, I will discuss root-derived carbon production in mixed space system, the influence of the root traits on the soil carbon, and the role of different agriculture practice in this process. Global soil carbon stock and its importance to worldwide. Soil plays a fundamental role in the global carbon circles. Alongside the atmosphere and the vegetation globally, soils store around the 2,400 gigatons of the carbon within the top 2 meters. To put this figure into the context, this amount exceeds the carbon currently present in the atmosphere, highlighting in the immense importance of the soil as a carbon reservoir. However, the storage of the carbon is highly sensitive to climate change, rising temperature, land use change, and the unsustainable agriculture practice can accelerate the carbon losses from the soil, undermining the both environmental stability and agriculture productivity. From a scientific perspective, preserving the soil carbon is essential not only for mitigating climate change, but also for ensuring the long-term sustainability of food production system. So the concept of soil carbon management has become increasingly prominent in the international climate policy, reflecting its critical role in achieving global sustainability goals. Carbon sequestration potential and economic dimension of agricultural soils. Agricultural soils represent one of the most important natural reservoirs for carbon sequestration. Modeling studies estimated that by the year 2050, croplands could sequestrate between 2 and 3 gigatons of the carbon dioxide annually by itself. To put this into the perspective, this corresponds of the approximately 5 to 7% of total global annual emission, making soil a critical component of the climate change mitigation strategies. Beyond the environmental benefits, there is also a growing economic dimension. The monetary value of the carbon sequestration continues to increase, largely driven by the dynamics of the international carbon markets. As the carbon pricing mechanisms expand, the economic incentives for sustainable soil management practice will become even stronger, creating opportunities for both farmers and the policy markets to integrate soil carbon into the climate and agriculture strategies. Impacts of the soil carbon on agriculture production worldwide. First, soil organic carbon is a fundamental indicator of the soil fertility. Soil that is rich in the carbon not only retain more water, but also improve the nutrient circling and enhance root development. Researchers currently demonstrated that such a soil can increase the agricultural productivity by 10 to 20% compared to soil with lower the carbon levels. Climate resilience, organic carbon-rich soil play a critical role in the building resilience against climate extremes. Field studies conducted after the 2020 showed that during the drought conditions, yield losses in the soil was limited to about 15%. However, in the soil lacking organic carbon, yield losses were much higher, reaching 30 to 40% under the same climate condition. Another food security dimension, the loss of the soil carbon is directly linked to food production and the food prices, making it a pressing global concern. FAO report that nearly 24 billion tons of the fertile soil are lost each year. If this trend continues, we could face the significant reduction in the food production worldwide by 2050 with serious implications for global food security. Soil carbon stock in the importance in Turkey. Turkey's soil is critical carbon reservoir, particularly in agriculture areas. They are highly sensitive to climate change as a rising the temperature, irregular rainfall, and the drought can reduce the soil carbon and impact crop productivity. Recent studies since 2020 have shown by 5 to 10% decrease in soil organic carbon in arid region, highlighting potential threats to food security and the rural livelihoods. Sustainable solution and agriculture practice soil carbon This slide summarizes the key agriculture practice and the innovative methods for increasing soil carbon sequestration. No-till farming has been shown to reduce the soil carbon losses by 20 to 25%. Cover crop contributed to carbon storage by adding the organic matter to the soil. Agroforestry or integrating trees with crops can increase the carbon sequestration. To their fault, organic fertilizer and the compost enhance soil organic matter, improving the overall carbon balance. In terms of innovative approach, biochar acts as a long-term carbon reservoir, remaining stable for the hundreds of years. Additionally, digital agriculture and the monitoring system use the sterilities and the sensor to track the carbon flow, which greatly facilitates the verification of the carbon credits and supports sustainable management practice. In this slide, we present all the study which focus on the plant root carbon production and soil organic carbon storage with mixed space cropping system. All project focus on the measuring the plant root carbon production and identifying root traits that contribute to soil organic carbon storage. We explore the relationship between climate, soil type, plant species, and both underground and above-ground plant compounds in relation to soil carbon. We investigated mixed space system and compared them with controls such as a monoculture or life diversity system. Our goal was to establish a comprehensive database that includes root biomass, root traits, shorts, yield, and both below ground and the above ground characteristics. Furthermore, this project aimed to produce the scientists and the method analysis that can be maximized and the adoption of environmental friendly agriculture practice and innovations. These analyses are intended to promote behavioral change among various stakeholders and the actors with the food system. Carbon sequestration mechanism in the plant root zone. Plant roots play a key role in transferring the carbon from the atmosphere to the soil. This process enhances soil organic matter and promotes long-term carbon storage. First, during photosynthesis, plant capture carbon dioxide from the air. Then the photosynthetic produce and transported to roots where they can be utilized locally. Root relies rheosphere extracted, which are the organic compound secreted into the surrounding the soil. This expedites stimulate microbial activity, allowing soil microbes to process and stabilize the carbon. Finally, through the humidification, carbon is transformed into long-lived organic matter in the soil, contributing to double the soil carbon sequestration. This slide presents all the field and the laboratory study conducted in the pomegranate orchard. To begin, nets were placed under the selected trees to ensure the roots of the mixed plant could be remained intact. After the plants completed their growth period, these roots were carefully transported to the laboratory. They were washed, separated, and cut into the fermenting soil depth layers. For each soil layer, root scanning and the carbon analysis we conducted separately. Soil samples from the same depths we are also analyzed for the carbon content. This approach enabled us to compare the carbon sequestration between areas with the mixed cropping and the control areas without the mixed crops. Overall, this methodology always us to explain the root and the soil carbon dynamics by depth and provides an objective evaluation of how mixed cropping influence soil carbon accumulation. Another method, flatbed scanning method. For this slide, we focus on the laboratory analysis of the root sample collected from the field. First, the roots were carefully washed and to remove the soil particles. Next, high resolution flatable scans we use to capture detailed image of the roots. The flatbed scanning method is commonly employed because it provides reliable and reproducible measurement of the morphological traits such as a root length and the diameter. Finally, the scanned image we analyzed using RioVision Explorer software. This allows us to evaluate the primarily physical characteristics of the roots in a detailed and systematic manner, which is essential for understanding root structure and the function in different cropping systems. In this slide, the physical properties of the plant roots were analyzed using the RioVision Explorer program. This program measures various parameters such as root length, density, surface area, find the root length, and the root diameter. Findings revealed that under mixed cropping system, roots spread more extensively in the soil. This expansion led to greater root biomass and the density, which in turn result in the high soil carbon accumulation compared to monocropping system. Furthermore, mixed cropping enhanced soil structure and significantly improved water holding capacity due to the increase in the fine roots. In conclusion, detailed root morphology analysis demonstrated that increasing the plant diversity provides essential ecosystem service by enhanced both soil carbon storage and water retention. These findings emphasize the need to consider root zone dynamic in the development of the sustainable agriculture system. Findings. Mixed cropping system play a circle role in enhancing soil carbon sequestration. This process not only improves soil health, but also strengthens the resilience of the ecosystem. By cultivating diverse plant species, we can support biodiversity and make important contribution to the global carbon circle. Root traits such as length, density, and the branch are particularly important. They can help increase the carbon accumulation and improve the soil fertility. Plants with deep and wider root system are especially valued because they can move more carbon into the deeper soil layers, allowing for long-term storage. Mixed forest crops are another advantage as they contribute to soil carbon sequestration while providing farmers with additional income from livestock feed. At the same time, this system encourages the soil water holding capacity, which is important for maintaining productive under drought conditions. In summary, mixed cropping represents a powerful stage for sustainable agriculture. It delivers ecological benefits such as the soil health and the biodiversity, while also offering the clear economic opportunities for the farms. As a result, root traits are fundamental for as the soil carbon sequestration characteristics such as the root length, density, branching, and the thickness directly determine how much carbon can be stored into the soil. Mixed cropping systems have been shown to increase organic matter in the rheosphere, which significantly enhance carbon storage when different plant species grow together. That improve soil carbon dynamics and lead to great carbon accumulation in the root zone. By increasing plant diversity, we can stimulate carbon sequestration, which in turn directly improves soil health and supports sustainable agriculture practice. This system also plays an important role in maintaining the carbon cycle of the ecosystem. Beyond the ecologic benefit, mixed cropping practice also offer farmers economic opportunities such as producing livestock feed. Therefore, this practice provides a dual advantage that support ecosystem health while so contributing to farmers' livelihoods. In summary, mixed cropping system represented a powerful stage to the enhance soil the healthy, improve resilience, and promote agricultural sustainability. Finally, recent research highlights that mixed cropping systems offer a great potential to improve soil health and increase carbon sequestration. These practices are not only crucial for climate change mitigation, but also advancing sustainable farming strategy. As the importance of the environmental friendly approach in agriculture grows, enhancing organic matter in the root zone becomes essential. This process supports carbon storage while improving the overall carbon productivity. By diversifying plant space, we can improve the soil health, adapt better to changing climate and the soil condition, and ensure long-term sustainability in agriculture. Additionally, Mixed cropping helps soil retain the more water, which is particularly important under the drought condition. It also enriches biodiversity, ensures the continuity of the ecosystem service, and provides farmers with the new income opportunities. In summary, scaling up mixed cropping system is aligned with global climate change mitigation strategy. It's not only staying health ecosystem healthy and agricultural sustainability, but also enhances resilience against the drought. Thank you for listening.
Thank you, Mr. Abdulkadir. Thank you so much. Have any question? موجود سؤال؟ Abdulkadir Bey ekranın ne oldu?
Yes, please.
Lamia, Dr. Lamia.
Yes.
تفضل.
Excuse me. Thank you so much for your amazing presentation, but I have some questions to answer, please, if you have, if you can reply it, please. First of all, what type or which type of soil did you use or for planting? This is the first question. Second one, do all soil plays or types play the same role in carbon sequestration when the same plant cultivated? If not, how to define? Third question also is how do you examine the correlation between plant root carbon and the soil carbon sequestration? Final question, did you test the effect of fertilizer type, amount, and form on the carbon sequestration or not? Thank you so much. I can type these questions in the chat if you need it.
Yeah, if you can type, it will be
Yeah.
good.
Okay. I'm so sorry for long questions, but you
Yes.
know, this is to clarify some points for me.
Yeah.
Yeah.
Okay. Give me a
Abdulkadir Bey.
second.
And there was a question in the for my presentation. It's about harvesting or pruning aspect in precision agriculture.
This is the first questions.
Okay.
Second.
As you type it, I will ask the old question.
Yeah, I just wrote it separately. 1, 2, 3, 4, 5.
Okay.
4. Okay.
For that question in the previous presentation.
Yeah, this is two questions.
He said, ask one of the listeners ask, how about the harvesting or pruning aspects in precision farming? It's variable rate application in precision farming is focuses on generally on inputs, not the harvesting monitoring is essential for the variable rate application because you have to see the effect of the applications on the harvesting methods. So it's generally focuses on inputs, but in the concept of precision agriculture, nowadays it's like with help of artificial intelligence, it's there is a kind of robotics for harvesting, especially for fruits. For image processing, they get image process in the fruit from their reflectance, and it decides about their maturity and harvest it automatically. But for variable rate application, it's mainly, as I said, focus on inputs, not in the harvest or life cycle.
Thank you, Mr. Ahmed. Dr. Lami.
I did write all my questions starting from 1 up to 4 in the chat. The first one, what type of soil did you use to plant?
First, answer. All soil are low the clay and soils. My plant soil.
is it clay soil or you mean loamy? I didn't get your point. I'm sorry.
Toprak yapısını soruyorum.
Clay?
Clay soil, yeah, okay.
Yes.
Okay.
Yes, Dr. Ayman Al-Uda.
Yes, good morning, everybody.
Good morning.
Can you hear me well?
Yeah.
Okay. First of all, I would like to highly appreciate this interesting presentation and thank you for Dr. Abdul Kader. As a matter of fact, all of us know that all the plants release a variety of organic compounds such as sugars, amino acids, mucilage, extracellular enzymes. These are collectively known as exudate or root oxidate, which have a very important role in the deposition and stability of the soil organic carbon. So my question is, how do the root architecture and characteristics can affect on the soil organic carbon deposit and stability? I mean, is there any effect for the root depth, root density, root composition, especially the chemical composition of the root? I mean, lignin and supreme for the accumulation of the carbon and the soil carbon stability. The second question is there any impact of the mycorrhizal association or the symbiotic association between the root system and the mycorrhizal fungi on the deposition and the stability of the soil organic carbon? The third question is, which part of the plant, I mean root or shoot, are more efficient in the accumulation of the soil organic carbon? Thank you very much.
Abdülkadir, bu soruların cevapları uzun. İstersen sadece mikorizle ilgili kısmını cevaplayabilirsin. Sonra internet üzerinden, mail üzerinden yapabilirsiniz. Bayağı uzun sürecek.
Yani aynı cevaplar başkanım çok aslında bunu bir özet olarak sen söylesek. biz yapsak.
دكتور أيمن، السؤال سؤال عملي وجوابه طول. بدون زحمة عليك، بالإيميل تواصلوا مع بعضكم أو الدكتور رايا هي توصلكم مع بعضكم. ليش هذا طول شوي؟ ظل عندنا ظنيتي 8 دقائق. إذا جاوبهن يطول والله. 3 سؤالات كل واحدة كتابة. الله يسلمك.
ما في مشكلة. اوكي، no problem.
شكرا. Thank you very much دكتور إيمان.
شكرا.
Yes, any question? دكتور رضا.
دكتور علي، شكرا لك، الله يسعدك ويسلمك.
الله يسلمك.
يعني سعيد جدا جدا بشوفتكم بالدرجة الأولى وبهالموضوع القيم اللي الشباب قاعدين يحكوا فيه.
شكرا.
أنا مش خبير بهذا المجال، بس يعني استمتعت جدا.
والله ما واضح جدا أهمية مهمات وحتى على الشرق الأوسط هذا الأشغال، هذا اللزوم نشتغل مع بعضنا. المواضع هذنا الملاح أول شيء، والجفاف دروت توليرنت بلانس، والكربون وبعد إن شاء الله بعد الكربون إن شاء الله.
تسلم.
والشهر الجاي إن شاء الله نعمل برزنتيشن على الأسمدة الموجودة عند الدكتور شاهين مردان، وبعدها واحدة إن شاء الله نرتب ثانية واحدة برزنتيشن الشهر المقابل إن شاء الله. وإذا ماكو سؤال. دكتور رايا،
أعتقد في سؤال من أكسات. ما بعرف يعني المركز العربي أكسات.
أيوه.
أسعد الله يعطيكم العافية، محاضرة كثير كويسة، بس أنا بدي أركز على ناحية إنه شو نحن فينا ننصح المزارع لحتى يزيد الخزين الكربون العضوي بتربته الزراعية. طبعا الشيء النظري معروف، هل يمكن من الناحية العملية اختيار أو نصح باختيار محاصيل محدده لزياده مفهوم الكربون العضوي في التربه بالنسبه للمزارعين.
Abdülkadir Bey, şimdi
Evet.
soru şu.
Hı hı.
Ahmet Bey de sen de hazırsın. Şu anda biz çiftçiye bunları nasıl önerelim? Yani çiftçiye şu anda uygulamaya aktarmayı nasıl yapalım? Pratikte nasıl olacak bu? Sizin bu bizim karbonla ilgili şeyler.
Şimdi başkanım ben böyle anlatayım. Biz bu mix root'u kullandığımızda, hani karışık bitki türlerini kullandığımızda yani çiftçiye bu şekilde anlatabiliriz. Bunu ikinci bir ürün olarak, hani en büyük katkısı da genelde kullandığımız meyve bahçelerinde, agroforestry alanlarında hayvan yemi olarak, hani ek bir gelir olarak çiftçiye sunduk. Hani bu yönden hem bahçesinin gelişmesi, hani karbon tutumu, topraktaki karbon tutumunu artırmak, hem de aileye ikinci bir ek gelir olarak işte bu hayvan yemi olur veya işte arpa, buğday çeşitleri
Evet,
olunca
evet,
farklı
evet,
gıda
evet.
olarak da sunabiliyoruz.
أخي أستاذ المركز العربي الأكساد، اسمك بالخير، أنا ما سمعت اسمك.
الاستاذ الدكتور محمد سعيد الشاطر.
دكتور محمد سعيد. دكتور عبد القادر جاوبنا جواب أكثر شيء بالفواكه هم أسس الفواكه يزرعون الميكست هذا وعلفه على الحصاد العلفية النبات، وبعد تحتها الميكس هذا يعمل كربون يفيد الفواكه. يعني معناته البراتيكلي هذا هي تشوف المزارعين الفلاح إذا عنده شجر فواكه أو زيتون أو ثاني شيء، يزرعون بين الشجر الميكس هذا، وبعد يحصدونه العلف للحيوانات، وتحت التربة الكربون هذا فيكسد، فايدة للشجر. هذه أول مرحلة للمزارعين توزعونها العلمية هذه. يعني فهمت على هذه.
طبيعي.
دكتور سعيد.
شكرا.
الله يسلمك. Teşekkürler Abdülkadir Bey.
You are welcome.
Yes.
سلام يا مرحبا.
دكتور رضا، رايا، وكل
ما بعرف any
المستمعين
questions.
والحاضرين، شكرا لكم. إن شاء الله الشهر الجاي بإذن الله إن شاء الله من تركيا حتى برزنتيشن 2 أو 3 نجهز لكم ما الطلب خاص، إذا طلب موجود رايا توصل لنا إن شاء الله. Thank you very much. Mr. Gökhan Kızılcık, he is head of our department from General Directory. Thank you.
شكرا دكتور علي، شكرا دكتور احمد، دكتور عبد القادر، شكرا لكم جميعا.
Thank you. Teşekkürler. Şükran. Allah يسلمكم.
Şükran, thank you.
مع السلامة.
شكرا تسلم، مع السلامه.
يعطيكم العافيه.
يا مرحبا، شكرا يا مرحبا.
يا اهلا وسهلا بكم.
نتمنى بالايام القادمه في عمل مثل الاعمال المميزه انه يكون اكساد مشارك بمحاضرات، فنحن عندنا خبراء بيضموا كل الاختصاصات اللي معروفه في القطاع الزراعي، ان كان بمستوى الانتاجي او مستوى الخصوبه او تحسين الاراضي او تحييد تدهور الاراضي، فعندنا طبعا خبراء بكل المجالات هي.
دكتور أنا سبق وبعثت إيميل يعني قبل فترة، طلبت من أكساد إنه يرشحوا لنا مجموعة من الخبراء يتحدثوا يعني بمجموعة من المواضيع، لكن ما وصلني منهم صراحة أي ريبلاي، فأنا من خلالك بطلب والله يا ريت، إحنا ما عندنا مشكلة.
إن شاء الله بالمستقبل يعني بتكون
يعني أنا رقم تليفوني والإيميل موجود عندكم
على طول عندنا سوريا شغال، في مشكلة بالاتصالات، فنتمنى المرات القادمة ما يكون أي مشكلة. الاتصالات.
شكرا دكتور محمد سعيد.
شكرا الله يسلمكم جميعا. تسلم يا
مع السلامة. Goodbye.
السلام عليكم.
الله معكم، مع السلامة، يا مرحبا، يا هلا.
Thank you.